Our project was called the Howlin Bubble Machine by Eric Saunders, Ben Lacombe, Chris Carnes, and James London. Over the course of this PowerPoint, we will go over the engineering design cycle as well as what we learned. The first part of the engineering design cycle is the defining the problem stage. For us, the problem was given to us. The main objective for our project was to create an automatically generated stream of bubbles that lasted for over a minute. The secondary objective of this project was to make our project unique while also trying to grab bonus points, which I will get to in a second. That brings us to the second part of the engineering design cycle, the criteria and the constraints. This project had a lot of don'ts. It had to operate automatically, meaning no hand cranks. It couldn't have parts from a commercial bubble blowing machine with the exception of bubble wands. Solution had to be made homemade, which means that there couldn't be any commercial solution. Batteries couldn't exceed 6 volts, limiting power. It had to produce bubbles continuously for a minute straight. It had to be easy to transport. Bubbles had to detach from the machine, which is harder than it sounds. And everything had to cost the group less than $40 to produce, not including what you already had. Optionally, for bonus points, we could also change the bubble size and the bubble frequency. We had these in mind before entering Step 3. Step 3 is the brainstorming and ideas phase. From pretty early on in development, we had the idea of mounting our machine inside of a wire wolf head that a member of the group had made. Everything was in there: the electronics, the motor, the fan, and the solution. We wanted to encase this with paper mache so you couldn't see the machine while bubbles spit out of the mouth. Here's the wolf head early in production, before anything was put inside.
We did research on the electrical components that we would use. First, we discovered that the motor could be run with only using a battery. We also discovered that it acts as an inductor, which stores charge inside the coils. This caused sparks to occur whenever we disconnected and reconnected the motor, but the sparks had low enough power that it wouldn't hurt anything, so we ignored it. We also discovered that a pedometer could be used to adjust the speed of the motor by varying the resistance. We used this information to create the electronics.
Having a rough outline of the logistics of the layout and electronics in the machine, we set our sights to the solution. We researched how to make better bubbles. The physics of bubbles are like the picture below. A bubble is 3 layers, a water layer sandwiched by 2 layers of soap. A bubble pops when this water between the soaps evaporates. What we found is that glycerin and corn syrup makes this layer of soap thicker, making the water evaporate slower. Corn syrup makes stronger bubbles, so we decided to add it to the solution that we had already involved dish soap and water. In an effort to receive bonus points, we researched how to create bigger bubbles. There are a few key ways. The first way is changing the size of the orifice you blow the bubbles from, as in, the bigger the bubble wand, the bigger the bubble. You could also increase the gas flow rates as shown in the plot below. At low flow rates, bubbles are at a constant size, but as flow rate increases past a certain point, so do bubble sizes. We had hoped to use the gas flow rate to increase both size and frequency of the bubbles.
The next part of the project is part 4, doing the development work. For this, the wolf head was already created, so we used the dimensions of the inside of the head for determining sizes and positions of the other components. We used a 1/4-inch wooden dowel to connect the motor to the disc that spins through the solution. First, we measured the diameter of the rotating piece on the motor, which is 1/16 of an inch, and then drilled that same size into the end of the dowel so that they could fit together. The disc was cut out of a plastic container lid with a diameter to fit inside the wolf head. The holes for the bubbles, as well as the hole in the center for the dowel to attach, were drilled out using a drill press. The container for holding the bubble solution was created by cutting 2 water bottles in half and fitting the bases together to a sufficient length to fit inside the wolf head. They were super glued together to become watertight, and then a 1-inch slit was cut out of the top for the plastic disc to rotate through the bubble solution.
Our next step was creating an effective solution to blow the best possible bubbles. From our previous research, we decided we needed to use corn syrup to improve the durability of the bubbles. Our first solution contained equal parts syrup and water, and two parts soap. However, the solution was too thick for the disc to rotate, in addition for the fan being too weak to blow the bubbles. We decided to opt for a spare hairdryer to provide a stronger stream of air. For our next solution, we diluted our previous recipe with 3 parts of water to thin it out, but this instead made the bubbles build up inside the container and eventually spill out. As you can see in the picture below, this test got very messy, and my room still smells like soap. However, like the 3 bears, our third solution was just right. 1 part corn syrup, 2 parts water, and 6 parts dish soap made it viscous enough to turn, but also give effective bubbles. After our developmental work was complete, we felt our work was sufficient enough to move on to our prototype build. We began by inserting everything we had into the wire wolf head we had suspended from the ceiling for easy access. To make sure we had everything secure but easily removable, we opted to use zip ties to secure the foam holding the solution container as well as the motor. By using zip ties, we could also adjust the motor in each direction to get the right angle we needed. We then began to find an angle for the hairdryer that would produce our desired result of a strong stream of bubbles. Before testing for the correct angle, we decided to mount the head to a horizontal piece of wood so it was secure. We then attached an 18-inch long 1x2 board using a bracket and a screw through the bottom to secure it in place, and then mounted the hairdryer with zip ties for easy access. After testing different heights and angles, we found our desired result of an angle that produced the most bubbles. We also tested and found that the low setting was effective in producing a medium volume of large bubbles, but the high setting produced a lower volume of smaller bubbles, fulfilling our optional objective.
What we learned. We found that each of us have different strengths. For instance, I was the most knowledgeable about electronics. Overall, everyone contributed in their own way. We discovered that with hard work, we are capable of more than we previously thought. Overall, this project was challenging, but in a combined group effort, we created a successful bubble blowing machine and had fun doing it.
Here are our references.